moving on to is lesson 7 of Trig 1. So this is the second lesson in graphing, and it's on page 551 of your student workbook. What we are getting into is transformations. So remember I told you from the very first unit that we started with, transformations is just the gift that keeps on giving. And, we spend this whole unit on transformations, and then we start doing other units, and then we transform functions within those units. So I purposely always do trig as my second last unit because there's no transformations in perms and coms, but I sort of start the course with transformations and then I end the course with transformations, with transforming in trig, and that just helps sort of review for the diploma. Okay, so there's 2 forms that you need to know, whether it's a sine graph or whether it's a cos graph, but transforming in trig is identical to what we've learned. The parameters are going to be, I believe there's going to be a couple new letters, but the parameters are going to be the same. So the A value, I want you to write, that is your vertical stretch. It is also your amplitude. So just off to the side, A is going to be the amplitude of the graph. So in the last lesson, we learned how to calculate the amplitude of a graph. So you look at the middle of the graph and the distance from the middle of the graph to the peak of the graph. That's your amplitude. So A is, yes, it is a vertical stretch, but it's also how you find it in your trig graphs. It's going to be the amplitude of your graph. The B value, right, which is in front of your X value, that is your horizontal stretch. The B value we'll do in today's lesson. The C value is going to transform your graph to the left or to the right, and that's going to be a horizontal translation. Depending on what your C value is. And your D value is going to move your graph up or down. So the D value is the vertical translation. And then from lesson 1, the D value is also the midline of your graph. So for example, if this was a +5, what that means, and you don't have to draw this, but what that would mean that the middle of my graph is going to be at 5. And then that would be like my sine graph. It just, the D value changes the midline of your graph, okay? What we're going to do in today's lesson is we're going to look at the A value and the B value. That's going to be lesson 7. And then tomorrow's lesson is going to be on the C value and the D value. So today we'll take care of 2 parameters. And then in the next lesson, we will take care of the last 2 parameters. Okay, let's look at class example number 1. So use your knowledge gained from the transformation unit to describe how the graph of the given function compares to the graph of y is equal to sine of x. So this is my original graph, right? And this is my transform graph. We're only looking at the A value and the B value. So if I was to say, like the original graph, right? There's an invisible 1 there. The A value would be 1, and what that means is the amplitude of the graph is 1, and we know that's correct, right? In a sine graph, the amplitude is 1. The B value would also be 1 in this graph, and I'll talk about in the next class example what the B value tells us, okay? If that's my original graph, though, and this is the transform graph, they want to know, well, what's happening? So just like we would have done in transformations, you would have said, okay, this is an A value of 1. What is an A value? It is a vertical stretch. So this transformation would be a vertical stretch by a factor of 2. Yeah, or sorry, the A value, you guys should be 2. That's the A value. So the transformation would be a vertical stretch by a factor of 2. And if I was to go into, you don't have to do this, you could just look up here. let's see what I have in here. Okay, so this is the graph of y is equal to the sine of x, right? The a value is 1. I'm just going to quickly change my window. Okay, so here's the graph of y is equal to sine of x. The period of this graph is 360 degrees or 2 pi. The amplitude of this graph, I changed my scale, but this would be 1. That's the amplitude of this graph. If I go and I change that 1 to a 2 sine of x, what happens to my graph is it stretches this vertically by a factor of 2. So instead of my a value being 1, my a value, it was stretched up. The a value is now 2. Okay, it did not affect the period. Okay, let's look what happens when we have a b value. So b is equal to 2. You guys know that b is a horizontal stretch. So we would say, okay, horizontal stretch by a stretch factor of, let's see if you remember the stretch factor. Neil, what would the stretch factor be if my b value is 2 and it's horizontal?
1/2.
Yes. Horizontal stretch by a factor of 1/2. Okay, so now if I was to show you this, what that's going to look like. So on my graph, the amplitude is going to be the same, right? So the amplitude of this graph is 1. So my a value is not going to change. The amplitude is 1, but it's going to be stretched horizontally by a factor of 1/2. So what that would look like sine 2 of x graph. So there was my original graph. So that was the original graph, and the period of this graph was 360 degrees. What happened with a b value of 2? My period now is half of that. So the period, if I said, what's the period of this graph? When does it start repeating itself again? It's going to be 180 degrees. So I just want you to make note, even though you don't have to know it for this example, what's going to happen is the b value is going to affect the period. So we said a is going to be amplitude, and the b value is going to affect the period of the graph. Okay, what they want you to be able to do as well, and what you're going to be able to be expected to do in your homework, is the replacement notation. So remember that this was an x replacement. So x is replaced with 2x. That would be the replacement notation. Y, it's a little bit trickier for y. It wasn't y is replaced with 2y. It was y is replaced with 1/2 y. Okay, so that would be the replacement notation for whenever you have an a value. Remember, it's like the opposite when we're doing a replacement notation. Okay, this one here, so that's my a value, is -3. That's a vertical stretch. So two things are happening because it's negative. You're going to say, first thing is a vertical stretch factor of 3. Remember, we always do the absolute value of a, right? So the absolute value is always the positive. So it's going to be a vertical stretch by a factor of 3, by a stretch factor of 3. And then what this negative means, that means that the replacement, when you have a negative for your A, remember the replacement is y goes to negative y. So if you have a y value and it's going to negative y, that is going to be a vertical reflection. Okay. So, and a vertical reflection about which axes did we cut? We cut the x-axis. This one here, that's our B value. Okay, so two things. B value, remember, is your horizontal stretch. So we're going to say, okay, this graph is going to undergo a horizontal stretch by a stretch factor of 3, because again, it's always the absolute value of B. And then the negative just means that there's going to be a reflection. So the replacement is x is being replaced with negative x. If I have a point and that x value becomes negative, it's going to go and be reflected there. That is a horizontal reflection about which axes did we cut? We cut the y-axis. I'm not technically done my replacement notation. I just did my replacement notation for the reflections. So I also have to take care of x is being replaced. So there's two things happening. X is being replaced with 3x, right? So the x comes out and 3x goes in. And then here's taking care of the negative, right? So there's sort of two things happening. This is your vertical stretch. That is, or sorry, that's your horizontal stretch. That's your horizontal reflection. To do the same thing up here, this is just taking care of the reflection. If I was to take care of this stretch, I would say y is being replaced with not 3y, y, it's the opposite, 1/3 y. That would be the replacement. Okay, so hopefully that reviews a lot, like nothing really new should be here. It should just be a review. Okay, B and C, I don't want to do right now. What we're going to do is we're going to complete this table. Okay, so what we're going to be looking at is we're going to be now figuring out the amplitude and the period just by looking at the graph without even punching it in. So we know that amplitude is the A value, right? So if I said, okay, well, what are the amplitudes of all these graphs? Remember that it's, let's write above here, y is equal to A sine B of x, right? That's with only our parameters A and B. So the amplitude is the height of your graph from the midline. So this is going to have an amplitude of 1. This guy is going to have an amplitude of 2. This guy is going to have an amplitude of 1. This one is not -3. Okay, so some students will be like, oh, I just want to write my A value, which is -3. Olivia, what would you say the amplitude of this graph is?
The absolute value, which is 3.
Perfect. Yep. This one would be 1. This one would be 5. So like this graph, if we type this in, it's going to have a height of 5 units from the middle of the graph. This amplitude is going to have a height of 1/3. And this one, a lot of students want to say the amplitude would be A. More correctly, though, it's the absolute value of A, right? Because if A is a negative number, like Olivia's example, -3, you couldn't say that the amplitude is -3. You'd have to say 3. So that's how we do amplitude. So nice and simple. You look at the A value to get the amplitude of the graph. Okay, the next one is period. And period is going to be the B value. Now we know that this graph here, a normal graph, y is equal to sine of x. If I said, what's the period of this graph? Well, I know that this graph starts at 0, has an x-intercept of 180 and 360, right? So if I said, what's the period of a sine graph? It is 360 degrees, right? The period of a sine graph is 360 degrees. So what you're going to do, this B value is 1. So the period is 360 degrees. This B value is 1. The period is 360 degrees. This B value is 2. So the period, it's whatever the original period is divided by the B value. So if your B value is 2, the period, and we're going to write this down after, but the period is going to be 360 degrees divided by your B value. So the period of this graph is going to be 180. The period of this graph, if it's 1, 360 degrees divided by 1 is 360 degrees. This guy is -3, but remember, it's 360 degrees divided by the absolute value of B, which is just 3. 360 divided by 3, the period for this graph, it's going to repeat every 120 degrees. This one, 360 divided by 4. So my B value is 4. So this period is going to be 360 divided by 4. If you type that into your calculator, this graph, it's going to have a height of 5 from the midline, and it's going to repeat itself every 90 degrees. Okay, this period would be 360 divided by 1/2, which is, so if I was to do the math, 360 divided by 1/2 is the same thing as 360 times 2. So 360 times 2, this guy would have a period of 720 degrees. And this guy is going to have a period of 360 degrees divided by the absolute value of B. So in order to figure out period, it's always, this is your formula. 360 divided by the absolute value of B, okay? Yes. Okay, E, describe the effects of parameter A on the graph. So A, remember, changes the amplitude of the graph. So we're going to say, so it affects amplitude. And therefore, and this is important if you're making a study guide, the A value affects the amplitude, which will affect the range, right? Because originally our sine graph goes from a 1 to a -1. Well, this one's going to go from the maximum Y value is going to be 2 to a -2, right? This maximum value is going to go from a 3 to a -3, so it's going to affect the range. And then I want you to write amplitude is equal to the absolute value of A. So whatever the number in front of the sine or cosine graph is, and you just take the absolute value of it. That's going to be the amplitude of your graph. That's the height of your graph from the midline. Okay, describe the effects of parameter B on your graph. So yes, we know that parameter B, we know that A is like a vertical stretch, right? But the vertical stretch is going to affect the amplitude. This, yes, we know that B is a horizontal stretch, but what that affects is period. So B value affects the period of the graph. Okay, so this will go on your study sheet. The period of your graph is going to be, how you're going to calculate the period, 360 degrees divided by whatever that B value was, the absolute value of the B value. Or once we start converting to radian modes, if I said, well, how would you find the period in radians? Well, 360 degrees is the same thing as 2 pi over the absolute value of B. That's going to be how you get the period of the graph. When does the graph start repeating itself? Okay. G, would you expect similar effects on the graph of y is equal to a cos b of x? Yes, the answer is yes. So again, yes, this is a vertical stretch, but that's going to be the amplitude. And this is going to be period is equal to 360 degrees divided by whatever the absolute value of B is. So it doesn't matter whether it's a sine or a cos graph, this is going to apply. Flip your page to page 552. So let's just write over here, y is equal to a sine b of x. Let's just write vertical stretch and horizontal stretch. And this is just notes on what we basically did on the last page. So if this A value is greater than 0, it's a vertical stretch. If the A value is less than 0, if it's a negative, it's going to be a vertical reflection and a vertical stretch by the absolute value of A. And then it does the exact same thing down here for your notes. So your B value is a horizontal stretch, it says. Remember, if B is 5, the stretch factor is 1/5. And then here's just saying if it's less than 0. So if it was -5, it'd be a horizontal stretch by a factor of 1/5. And the negative just means it's a reflection, a horizontal reflection. Okay, so all of this, nothing is new here. This here, I've got boxed in. And I often tell students that are making study sheets that this should go on your study sheet. So this would have already been on your study sheet, like if you're doing from lesson 6, right? So how we calculate the amplitude of our graph is the max minus the min divided by 2. So that's already on there. You should have the formula for midline, right? So if you want me to give you guys that, because that should be on your study sheet. So the midline of your graph is the D value, which I guess the reason why they don't give this is because this will be tomorrow. But just to quickly review how you get that, it's going to be the max of your graph plus the min. Right? How do you get the middle? The middle is the average. So the max plus the min divided by 2. Here was what we were talking about for period. Tan is a little bit different. And tan is sort of a little bit difficult to discuss because you haven't actually seen, unless you've done the podcast, a tan graph. So I'm going to quickly show you a couple things about, I'm going to show you on my calculator for tan, why there's no amplitude for a tan graph, and why the period is 180 divided by B. Okay. So a couple of things I'll just quickly show you. So if you guys were, actually, if everybody could take out their calculators, and I want you to put in So tan of x, put that into, so I'm in radian mode. So tan of x here. And let's just go to window. And let's change our window. Let's go from 0 to 2 pi. So 0 to 2 pi. And let's have our scale be pi over 3, doesn't really matter. And then let's do the same min max. Actually, for amplitude, what I want to show you, let's go from actually -5 to 5. So -5 for your min, 5 for your max, and a scale of 1. So when you guys actually start graphing and looking at y is equal to tan of x, this is the graph of y is equal to tan of x. So it looks a little bit scary. But what's happening is there's going to be vertical asymptotes here, which will be explained in the podcast. So there's a vertical asymptote here, and there's a vertical asymptote here. What happens is this graph goes forever up. This piece goes forever up. This piece goes forever down and forever down. Actually, if I change my window, you don't have to change yours, but if I change it to, let's say, -2 pi, it'll give you a better picture. Yeah, so it's this shape that just keeps happening over and over again. This is the shape of a tan graph. And all of these are, like I said, vertical asymptotes are going to be here. And then, and if I said, okay, well, how often does this graph repeat itself? This is 0. That's 180 degrees. That's 360. This is -180. So if I said, how often does this graph repeat itself? Every 180 degrees, that's the period of a tan graph, okay? So the period of a tan graph is 180 degrees, because from here to here, it's 180 degrees. So I want you to write for this, so y is equal to the tan b of x. So write down y is equal to the tan of x. The period of this graph is 180 degrees of a regular tan graph, right? Because remember, this b value would be 1, so 180 degrees divided by 1. For tan graphs, they repeat every 180 degrees. There is no amplitude for a tan graph, because if I said, like, sketch a tan graph once you guys get comfortable with this, it's that same picture. So it would be essentially this is what you would sketch for a tan graph. And then every 180 degrees, so that would be 180 degrees, the graph is going to do the same thing. Then 180 degrees later, we'd be over here at 360 degrees, and the graph would do the same thing. If I said, what's the amplitude of this graph? It's impossible to calculate, right? Like, there is no amplitude. It's not applicable because this goes up to infinity. And then how often it repeats is 180 degrees. So you might want to draw like this sketch on your study guide for tan. Okay, let's look at class example number 2. Consider the graph of y is equal to 4 cos 2 of x. So we'll hopefully do this one quickly. We are going to punch it in our calculator. This tells you what mode to be in. So it's going to be a cos graph, and they want it to be in radian mode. This is my A value. So that's my A value, that's my B value. A is equal to 4, and that means my amplitude is 4 units. Okay. What's the period of this graph? So a regular cos graph has a period of 2 pi, right? So the period, you just have to sort of have this memorized because it's not on the formula sheet, but the period is going to be 2 pi divided by your absolute value of b. So it's going to be 2 pi divided by your b value is 2. So this transformed graph is going to have a period of 2 over 2 cancels, pi radians. So the original period is going to be 2 pi's. And now the graph is going to repeat itself once we do this transform graph. Every pi radians, it's going to repeat itself. So B says, sketch the graph on the grid use a graphing calculator to verify it. We're only going to do one sort of sketch, and then I'll show you on your calculator. Let's graph, and I'm going to do mine in green. So if you have 2 different colors, this would be helpful. Let's graph y is equal to cos of x. Okay. So if I said, okay, let's graph this really quickly. What's the graph of y is equal to cos of x? Draw your Cartesian plane. And you always want to get your 4 points in. So that point is 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. Okay, cos is which letter? So Claire, is cos x or y?
X.
Yes, so I'm going to put C's underneath all my x values. Okay, so at 0, the cos of 0 degrees is 1. So first, I'll do this in green. So just what the original graph of y is equal to cos of x, remember it has an amplitude of 1 and a period of 2 pi or 360. So when x is 0, y is 1. At pi over 2, at pi over 2, so where would pi over 2 be? I'll show you how to, we'll do the scale in a, actually let's do that, we got to figure out what the scale is. So we got to find where pi over 2 is. So see if you could figure out what the scale of this is. Count how many hatch marks it takes you to get to pi. Justin, what would you say the scale is? What is 1 hatch mark worth?
Pi over 6.
Yes. So you guys watch 1, 2, 3, 4, 5, 6. Pi over 6. So if I said, where is pi over 2? You know it's going to be halfway between, it's going to be 3 units, right? Because if that's pi, and that's 6, it takes 6 hatch marks to get there. This is going to be right here, pi over 2, but here's how we could count it. 1 pi over 6, 2 pi over 6, 3 pi over 6 is the same thing as pi over 2. And then at pi, so here at pi over 2, we're back to 0. Here is pi radians over here, cos is negative 1. At 3 pi over 2, cos is 0. So again, halfway between these, which would be right here, cos is going to be 0 at 3 pi over 2. And then back to 2 pi, cos is going to be at 1. So this is the original graph of y is equal to cos of x. It has an amplitude of 1 and it has a period of 2 pi. It's going to repeat every 2 pi. What we're going to do is we're going to just graph this on our calculator, and I want to show you how this graph is going to have an amplitude of 4 and it's going to repeat itself every pi radians. So what I want you guys to do is take out your calculators. What we're going to have our scale become, so for our x's, we're going to go, let's just start from 0 to 2 pi. So 0 to 2 pi, and then our scale factor is pi over 6. Each hatch mark is worth pi over 6. For our y's, let's just go from, -4 to 4. And each hatch mark they want to be worth 0.5. Okay, so make sure your calculators are out. Make sure first you're in radian mode. So I'm in radian mode. Let's punch in the original, which was cos of x. Let's do our window. So they want it to go from 0 to 2 pi. And the scale factor, they said pi over 6, or we calculated to be, the minimum is -4 to 4. And the scale factor is 1/2. There. That's your graph of cos of x, right? So this goes to 2 pi. This is one complete period, and then it's going to just keep repeating that exact same shape. The amplitude of this graph, remember each of these hatch marks is 0.5, so the amplitude is 1. That's at 1. The peak of this graph is at 1. Now in y2, let's graph 4 cos, what is it? 2x. Let's check that our amplitude is now 4, and let's check that the period now is going to be pi. So hopefully you're able to see this, but from the midline, which is right here, to the peak of my graph, that's my amplitude, and that would be 4 units, because remember it's going up by 0.5s. This graph, one period, if I go from peak to peak, it would be from this peak to this peak, and that is at pi radians. So this graph repeats every pi radians. And we're not going to actually graph this one because it's complicated to actually stick this on the graph because it doesn't have really nice intersects here. But that's what you have to be able to look at and understand, the two things. The amplitude of this graph is 4. And the period of this graph, it changed. The blue graph had a period of 2 pi. The red graph now repeats every pi radians. Okay, let's do class example 3. Before we do class example 3, we're going to be writing equations. So let's write the general form. A sine b of x. Write the equation of a sine function that has an amplitude of 2/3. Amplitude is super simple. Whatever the amplitude is, that's your a value. So my function is going to be, I'm going to take out that a and I'm going to put in 2/3. 2/3 sine. Now we just have to figure out the b value. So this tells me that I'm in radians, right? The formula, you guys, was this. Period is equal to 2 pi divided by b. If I say, well, how can we calculate this b value? If I say, let's isolate b, the formula for b is you simply just interchange those two. So the formula, or how you get b, it's going to be 2 pi divided by the period. Okay, so the b value the period is pi over 6. 2 pi divided by pi over 6, that is the same thing as 2 pi times the reciprocal, which is 6 over pi, pi and pi cancel. My b value is 2 times 6, which is 12. That would be your equation. Okay, so let's look at B and see if this makes sense. They want the graph of a cosine function having an amplitude of 3. So nice and easy for amplitude. A is equal to 3. So let's start filling it in because we know that it's A cos B of x. So A is 3. 3 cos. Now we just got to figure out the B value. Okay, so in order to get the B value, this is your formula, and it is 2 pi, which I'm not even going to do 2 pi because this has to be in degree mode. So what I'm going to do is I'm going to say, okay, so instead of 2 pi divided by a period, it's going to be 360 divided by the period. That's how you get the B value. 360 degrees divided by the period of 720. (360 degrees divided by 720) is 1/2. And that is your equation. This graph would have an amplitude of 3. So from the middle of the graph to the peak, it's going to have a height of 3 units. And the B value is 1/2. So it's going to repeat itself every 720 degrees. Okay, a tan function having a period of pi over 2. Okay, it doesn't tell me anything about amplitude, so our amplitude is going to be 1. Oh, actually, we don't even know. Remember with tan amplitude, we don't even say because it goes to infinity, so it doesn't have an A value. So this is technically incorrect. It should just be this. Y is equal to tan B of x. There is no A value. That's what it is for a tan graph. Okay, the formula, remember, for tan, so this is what we were looking at. In order to get your B value, remember that the period of a tan graph is 180 degrees or pi radians. So in order to get the B value for a tan graph, it's going to be, because this is in radians, it's going to be pi, because the original period of this is, it repeats every pi radians. So it's pi divided by the period. So the B value is pi divided by pi over 2. And that's the same thing as pi times the reciprocal. Pi and pi would cancel to give me a B value of 2. So the equation of this graph would be y is equal to the tan 2 of x would be the equation. Okay, second last class example. So example number 4. Consider the partial graph shown, state the amplitude and the period of the graph. Okay, so amplitude is the center of the graph to the peak. So if I said, okay, so we know that this peak here is at 3. So these peaks are at 3. These peaks, -1, -2, are at -3. So if I said to you guys, well, what's the middle of the graph? What would the midline of this graph be? I hope that everybody sees that the midline is 0. So let's actually, if you have a ruler, I want you to put the midline in. Because this will be helpful for tomorrow. You'll need this. So the equation of this line here is y is equal to 0. What we're going to do tomorrow, that's going to give us the midline of the graph, but the midline of the graph is the d value, and it's going to be 0. Okay, so once you know the middle of the graph, you could figure out the amplitude of the graph. So from the midline up to the peak, that distance is 3 units. So the amplitude, which is equal to the a value, is equal to 3 units. Sorry, the amplitude is 3 units, the a value is just 3, okay? But that is how you get that. If you wanted to confirm by doing the formula was max minus min divided by 2. The max of this graph is 3. The min of this graph is -3. And you divide that number by 2. 2 negatives gives you a positive. 3 plus 3 is 6/2. The a value is 3. Okay, the period of the graph. So let's write period is equal to. We have to find when the graph repeats itself. And in order to do that, we should figure out what the scale of this graph is. So hopefully you guys are good now at scale. And it's actually given to us because the first hatch mark is at pi/2, right? So this scale, because that's the first hatch mark, that is my scale. So that's pi/2, 1 pi/2. This guy would be 2 pi/2. This guy is 3 pi/2. This next one would be 4 pi/2, 5 pi/2, right? And 2 pi/2, if we reduce that, that would be pi. So if I said, what's the period of this graph? I think the easiest way would not be going, so this is why you have to understand both ways. It would not be going peak to peak because you're going to be doing a lot of math to be figuring out peak to peak. You're going to be taking pi/2 and dividing it by 2, and it's a lot of math. So I wouldn't go peak to peak for this one. I would go from the midline, 1 complete revolution, and that period is pi radians. So hopefully you guys see that this graph is going to repeat every pi radians. So that's 1 pi/2. Sorry, just let me think about this. 1 pi/2, 2 pi/2, 3 pi/2, 4 pi/2. Yes, this would be 2 pi. So it repeats every pi radians. Okay, so that's A. B, determine the equation of the sine function. So it's y is equal to A sine b of x. I know my a value was 3. my B value, because we're in radians, and remember if it's sine or cosine, it's always 2 pi divided by the period. The period is pi. So the B value is 2. That comes out, a 2 goes in, and then your x. And that would be your last one, or that would be your equation. So if you're to punch that into your calculator, set your scale or your window based on what we see up here, you would see this exact graph. Okay, the last question in this lesson is a practical application question. And it's this guy right here. Okay, the graph affects, the graph represents the effects of tides on sea level over a 24-hour period. And it's a coast graph, it's telling us. Okay, so what's happening here, just to sort of explain this. Okay, so this is about tides in a harbor. So what happens, this is sort of harder for us to sort of visualize because like Edmonton is landlocked, but anybody that's like spent a lot of time in BC or near an ocean, what happens is the tide comes in and the tide goes out. So ships have to always, there's a harbor master at every single port, and the harbor master knows exactly when the tide is high. And when the tide is high, boats come in. What happens is if your boat is at a port, so ports like where you get off on a cruise or something like that, if your boat is in a port and the tide goes down, if you're a cruise ship, it's going to ruin your boat. Like if this ever happened to a cruise, that would be like $1 billion worth of damage because these boats are what's called like beached or they're grounded, but these are small little boats, right? So the tide went out and these boats got grounded, not a big deal. If these were like huge, giant cruise ships, they would need to know exactly when the tide is going out because they would have to go back out to sea, right? They cannot be grounded. So like somebody's job is actually to figure out the tide levels. When's the tide the highest? And when the tide is the highest, all the boats come in. People on cruises get off the boats. And then when they're going to leave is when the tide is going to go back out to sea. Okay, so that's sort of how this tide works. Okay, so let's just look at this graph and see if we could figure out the equation from this graph. So we know that the equation, it's a coast graph, they just told us. And we'll start with what we know. Y is equal to, it should actually be A cos B of X. Okay, so the A is the amplitude of this graph. What's the height of this graph? So hopefully if I say to you guys, what's the amplitude of this graph? It's going from 4 to -4. That means that the midline is here. If that's the midline, the distance from the midline to the peak is 4 units. So A is equal to 4, the amplitude is 4 units. And now we just have to figure out what this B value is. Okay, so this is a coast graph. Whether it was cos or sine, it doesn't really matter. But in order to find the B value, whether it's cos or sine, it's always going to be 2 pi divided by the period. Oh, we need to get the period of this graph. So if I said, what's the period of this graph? Well, let's do the scale first. So the scale, we don't have to calculate anything. The first hatch mark is 3 units. So this is 3, 6, 9, 12, right? Goes up by 3. So if I said, what's this, what's the period of this graph? When does it repeat? Let's look at it in two ways. We could go peak to peak. So the period of this graph goes from 0 to 12. So the period is going to be 12. Or you could have done, like, let's say you said, okay, is there another way we could have gotten the period? Yeah, you could have, let's say, started here. That would be your shape there before it repeats itself. From 3 to 15, or 15 minus 3 would be 12 units. This graph repeats itself every 12 units. Okay, so if you're able to see the period of this graph, it's b value is 2 pi divided by period, which is 2 pi divided by 12. And therefore the period of this graph is pi over 6. So, or sorry, the b value. That's my b value. So b comes out, pi over 6 goes in, and then you just put a little, we normally would put an x there. Okay, so normally this would be the equation of my graph, right, the way we've done it. But now what we have to do, because this is a real life scenario, this is the height of the tide at any given time. So we've got to change our y to be exactly what they want it to be. The height of the tide at any given time. It's 4 cos. Our b value is pi over 6. And x is t, right? They changed the x. X is going to be time. And so for whatever port that is, that's the equation that, like, the harbor master would use to figure out when the ships can come in, when they must go out. Okay. There is no podcast for this lesson. The podcast, I'll assign some more tomorrow. This would be your homework, so it's quite a bit of homework. Number 1, 2. I just want you to do for both of those A and C. 3 to 8. 10, 12, and 14 to 16. Before you're able to do number 10, I have to show you how to do number 9. So number 9 is quick, but I'll show you that. If you guys could flip to page 556, I'll quickly show you number 9. Okay, they want us to figure out the equation of this graph, and they say it's a sine graph. And they say has a maximum value of 3 and a minimum value of -3. So this graph is going up to 3, and then if I was to continue it, it would go down to -3. So what I want to show you, the reason why I want to do this one is they didn't actually quite finish this, but if we were to finish this graph, it would look something like this. This minimum value would be -3. Okay. So one period would be like, that's when the shape would repeat itself. So a few things, many of you would be able to easily get the amplitude of this graph, and you'd say, okay, you could obviously tell that the middle is 0. So from 0 to 3, the amplitude is 3 units, right? So this is going to be 3. To figure out the period, remember for b value, we need the period. If I said, well, what's the period of this graph? What they've given me from here to here, I hope you guys could sort of see this. This would be half the period, right? Because the period would be one complete picture, and then it repeats itself. So this, from this red dot to this red dot, that's half the period. So half the period is pi over 2. If I said, well, what's one full period? You would take, if this is half a period, you would take that number and you'd multiply it by 2, right? If half the period is pi over 2, where this is going to finish is pi, the period would be pi over 2, multiply it by 2. That would be 2 pi over 2, and the period of this graph would be 2 over 2 is just pi. So this would be pi radians. This is half of a pi. This would be a whole pi. So this is half of a period. That's the whole period. And now you'll be able to calculate what the B value is, because B is equal to 2 pi divided by period. So 2 pi divided by pi, the B value is 2. And that's the equation of your graph. Y is equal to 3 sine 2 of x. Okay, so I'm just going to quickly stop this recording.